Hi all, today we are going to see the concept of minimum spanning tree. Uh, First we will see what is called spanning tree. So a spanning tree is a subset of the graph G which has all the vertex covered with a minimum possible number of edges. Now you can see here a triangle shape graph is there. So A, B, C totally 3 vertex is there covered with 3 edges. Okay. Now you want what is spanning tree means? Now you want to cover all the vertex with the minimum number of the edges. So what are the possible? See the movement of my mouse. This one is one possible. This is one possible and this is one possible. So totally 3 possible is there. So this is the way you have to calculate the spanning tree. Now going for the next slide. So spanning means totally how many vertex. For example, 5 vertex is there means you need to create 5 minus 1 edges. That is n vertex is there means n minus 1 edges should be there. Okay, and where the application we can use this means in civil network planning, computer networks routing protocol, clustering analysis. So like this plenty of examples there. Now we can directly go to a problem. You can see here for finding the minimum spanning tree, there is two type of algorithms there. One is Kruskal algorithm, another one is Prim's algorithm. So two algorithms there. We will see one by one. So first we will start with Kruskal algorithm, then we can go for Prim's. Now you can first before going to start Kruskal algorithm or Prim's algorithm, first you want to know the minimum spanning tree in detail with weighted graph. So here one weighted undirected graph is there. See the movement of my mouse. Now for this graph you want to calculate minimum spanning tree. I already told you what is spanning tree. So spanning tree means you need to cover all the vertex. So totally 4 vertex is there with the minimum number of the edges. So to cover all these vertex, minimum number of the edges. So what are the possible path is there means you can draw like this or like this, or you can also draw like this. So like this plenty of thing is there. So here now suppose if I take this path, so what is my weight? Total weight means 4 plus 5 plus 2, that is 11. Suppose if I take this path means 4 plus 1 plus 2, so totally 7. Suppose if I take this path, n shape is there, na? So 4 plus 3 plus 2, so totally 9 is coming. So the minimum weight is 7. So the final answer is this one. Now we'll here this minimum spanning tree follow a greedy method. So we know the concept of greedy. So greedy algorithm obtains an optimal solution by making a sequence of the decision. So these decisions are made one by one in some order. And one more thing, once the decision is chosen, it never change. We can't change it again. Okay, the same manner we are following. Now we can see a little big problem. Now we can see this. This is one structure is there. So in they will give this complete setup. So totally how many vertices there means 1 2 3 4 5 6 vertices there. So this Avanford, Brinslin, Cornwall, Donster, Eden, these are the places in Russia. Just take given one example. So now they want to make a cable connection for all these places. So what is the distance between Avanford and Brinslin means 3 km. 3. Now we can take 3 km like that. So for better understanding, let us make this Avanford, Brinjal, Cornwall as A, B, C, D. This is A, this is B, C, D, E and F. So now our diagram looks like this one. Okay, now we can go for the solution. What is the step 1 means? Write all the edges in increasing order. So which one is the starting edges? 2 is the minimum path. You can see here ED or DE. You can write in any order. So I will take ED is the first thing. The next edge is this one AB. The next one is AE or EA, anything, or CD or DC. And BC is the next one. Then EF, then CF, then AF, then BF, okay, then finally CF. Okay, so we have written all the path. Okay, now we are going for next step. Once you written all the thing in increasing order, now take from starting. So which one is the minimum ED? So take ED. So like this, mark ED and put and try to connect all the vertex. If it forms a circle, you need to stop that. Next minimum path is AB. So AB. The next minimum path is CD or DC. You can put AE also. Nothing. There is no wrong. Next one is AE. The next one is if you put BC as next one, it will forms a cycle. So your problem is wrong. So you need to remove that cycle, and next one is EF. You can stop the problem here. You can, because you connected all the vertex A, B, C, D, E, F. All the vertex are connected. So now calculate the total distance. 3 plus 4 plus 2 plus 4 plus 5. Total is 18. So this is the problem for Kruskal algorithm. So for this problem, a simple algorithm is given here. You can read this, and using this algorithm, you can start solving the problem. So the algorithm I will explain in start. The first one is remove all the loops and parallel edges. What is loops and parallel edges? Means, for example, you take this diagram, this question. For example, from A to B there is multiple path will be there. This is one part. Suppose one more path is there, another path is there. Like this, plenty of path is there from A to B. Means you can choose which one is the minimum that you can take. That is step number 1. Next one is self loop. A to A, B to B. If it is there, means you can remove that loop. Once you remove this alternate path and self loop, you can start your problem by arranging everything in increasing order. Okay. So this is the algorithm. Also, this is the algorithm, and plenty of problem is there. This is one type of problem. This is one type of problems. The same thing, and this is one type of problem. For this, we want to apply Kruskal algorithm. The final result will be like this. Yeah.